Okay, here's the limits test part 2. Again, I'm on form A, so if you have a different form, just find the corresponding problem. First one was to find the limit as x approached 3 of f of x. And when we find this limit, so it's x divided by radical x squared minus 9. You plug in 3, you get 3 divided by the square root of 9 minus 9 is 0. Or 3 divided by 0. We know for limits this can go to infinity, negative infinity, or DNE. And so we have to kind of plug in a number just bigger than 3 and just smaller than 3 to get it from the right and the left. When we plug in the number smaller than 3, like say we plug in 2, you notice that we get 4 minus 9, which would be the square root of negative 5. And we cannot do the square root of a negative number. So this limit is DNE, because coming from the left side, it just doesn't exist at all. Is f of x continuous or discontinuous? Well, it's going to have to be discontinuous, because if we remember our 3 discontinuity rules, the first one said that the limit as x approached that value a, and in this case it'll be 3, right, because it's at 3, does not exist. The limit has to exist. In this case, it doesn't exist, so it's discontinuous. Alright, vertical asymptotes, that's when we set the denominator equal to 0. So we're going to set the radical of x squared minus 9 equal to 0. Square both sides. We'll add over 9. We get x squared equals 9. Take the square root. We get x equals plus or minus 3. And then horizontal asymptotes, this one was a little trickier, but we have to check the limit as x approaches infinity of f of x, and we have to check the limit as x approaches negative infinity of f of x. Okay, now in this case, we have, instead of f of x, we can write x divided by radical x squared minus 9, and this becomes the limit as x approaches infinity, right? If we kind of only care about our bigger exponents, that's going to be x divided by, now the square root of x squared gives us absolute value of x. It's x, right? Those cancel out, but basically it's telling us that this has to be a positive number. Okay, so now this is just infinity divided by infinity, or just 1, right? Because those can cancel. When we do the negative case, we get the same x divided by absolute value of x. But now when we plug in negative infinity, right, we get negative infinity divided by positive infinity, which becomes negative 1. So we have 2 asymptotes here. We have y equals 1 and y equals negative 1. And that was a little bit of a trickier question. Alright, number 2. This is the one where you would have wanted to use your calculator. And on number 2, if you plug in these values, so if you plug in those values to your calculator, you get these answers. And I'm not going to go over that right now, how to do that, but if you need help plugging it into your calculator, talk to me and we'll go over it. So now part B says that according to the table, predict the limit of g of x as x approaches 1 from the left side. So that means we're going towards, x is going towards 1, and from the left side, or basically saying left meaning numbers smaller than x, right? So it's from numbers smaller than 1, so going higher and higher. That's basically saying we're going this way. 4.9, 4.99, 4.99. That tells me those numbers are getting closer and closer to 5. So the limit as x approaches 1 from the left side is going to be equal to 5. And then the limit as x approaches 0 from the right side, that's like saying we're getting closer to 0, but from the right side, 4.2, 4.1, 4.01, 4.001, these numbers are getting closer and closer to 4. Alright, average rate of change, that's f of b, or in this case g of b minus g of a divided by b minus a. Alright, so that's going to be equal to g of 0.8 minus g of 0.2 divided by 0.8 minus 0.2. And we plug in g of 0.8, that's the y value, that's 4.8 minus 4.2 divided by 0.8 minus 0.2, and we get 0.6 divided by 0.6, which is just equal to 1. Alright, our next question says sketch a graph that satisfies these requirements. First we have x is approaching negative 1. I'm just going to kind of make a dotted line there to help me out. And the y value, right, this is our x value, this is our y value, is equal to 2. I'm going to put an open circle there. And going to the right, it's going to go to the right. Then I have negative 1, the y value is 0. And this is going to go off to the left. And then at positive 1, my y value is negative 1. So I know the graph needs to go through that point. Now I can basically connect this however I want. I'm just going to connect it there. And this one needs to go through that point. If it doesn't go through that point, it's not a function. Alright. Then we have number 4. And I'm not sure why my graph got messed up, but I kind of tried to fill it in there for f. So the first one says the limit as x approaches negative 2 from the right side. So that means we're going towards negative 2, right, from the right side. So that's going to be equal to 0. Then towards negative 2 from the left side is equal to 1. And since those are different, just towards negative 2 is d and e. Then letter D says going towards negative 1. It doesn't give me a left or the right, so that means it has to be the same from the left and the right, and it is. Both of those go towards negative 2. Notice that it's still an open circle, but it's a limit, so it's okay because it's going towards that number. Then if we actually plug it in, the actual value up here is equal to positive 2. Alright, letter F. This is the same as saying the limit as x approaches negative 3 of f of x times the limit as x approaches negative 3 of g of x. And the limit as x approaches negative 3, if we notice, it's an asymptote that goes to infinity and negative infinity. So this one here is d and e, and d and e times anything, it'll end up being negative 2, is still just d and e. Alright, g, this is the same as saying the limit as x approaches 0 of g of x divided by the limit as x approaches 0 of f of x. The limit as x approaches 0 of g is equal to 1. The limit as x approaches 0 of f of x, it's going towards 0. So this is 1 divided by 0, which is d and e. You can't divide 1 divided by 0. Okay. Letter H. Okay, we're going to do the limit. For letter H, we're going to, basically go to the inside first. So we're going to plug in 1 to that f of x. So the limit, right, of x approaches 1 of f of x, and then we're going to do g of that answer. So the limit as x approaches 1, right, that's right here, is equal to 0. So this is like having g of 0, and g of 0 we said is positive 1. Here, we plug in 1 from the right side, and then we subtract 3. So this is the same as having the limit as x approaches 1 from the right of g of x, and then subtract 3 to that answer. So we go to g from the right side, that limit is equal to 2, and then we subtract 3, we get negative 1. And then lastly, this limit here, we have to plug in 0 first. So we get f of 0 plus 2, or f of 2. And at 2, we have f is equal to negative 1. Alright, there's part 2 of the test. Let me know if you guys have any questions, and good luck on that retake.